I am Anil Kumar. Welcome to my series on trigonometry. In this unit, we have discussed about oblique triangles, that means triangles having any angle but not 90 degrees. We learned about sine law, cosine law. We also looked into some special cases of finding area of a triangle. Two cases, one derived from the other, are where you are given two sides and an included angle, or when you are given two angles with included side. The formula for both are given on this particular slide. The question now for you is find the perimeter of the trapezium from area. So that is the concept. We need to do some reverse calculations to get our results. A trapezoid is shown to you in the figure. The area of the trapezium shown in the figure is 7,000 meters square. Find the perimeter of the trapezium. That is the question. So to find the perimeter of this, you basically need to find the side shown here, A to B. And then you can always add and get the result. So I'd like you to pause the video at this stage, take it as an exam review. This is one of the challenging questions. Think about a strategy and then solve the question. Now, let's talk about the strategy and then we'll see a very simple solution to this complex question. Now, you have been working with triangles, and in trigonometry, we should always divide a figure into triangles to solve. What you observe is that we are given two sides and an angle. Of the top portion, we have these two sides and the included angle. So if I divide this into two triangles connecting B and D, in that case, we do form triangles which we could work with the given formula. So we have now two sides and an included angle. That means the first case, and we can find the area of this using half AB sine C. Now getting to the next one, so let me call this as area 1, we can calculate, and now next one, area 2. In this particular case, what we don't know is AB, right? So we don't know what is this length A to B. But fortunately, we have the area given to us. So A2 kind of is known to us, but not the side. But again, we can use the same formula and find the area and then the side. So I hope the concept is absolutely clear. So the formula which is going to be used is area is equal to half of adjacent sides A and B and sine of included angle. So treat like this, right? So these are the two adjacent sides and side and the included angle. Now with that, I'd like you to now pause the video, answer the question, and then do your calculations. I'll also try to do calculations and let us confirm our answers. So now let's begin the solution. So now we understand this strategy. Let us now solve the question. So the line shown is dividing the trapezium in two parts, A and B. We'll call them area 1 and area 2. So let us say that this particular part here is area 1 for us. This is area 2 for us. What we need to find is side length A to B. And we are given the total area of 7,000. So let's do the needful. We can say that the total area A is equal to sum of the two areas A1 plus A2. Now each area we can find using the formula, which is when we know the two sides and the included angle. In that case, the area formula is, let's rewrite the formula for area. So area is equal to half of AB sine C. So that's the formula which we are going to use. We are given the area of 7,000. Let's write down the area of 7,000 first. And the area of first side will be half of the two sides mentioned are 75 times 70 and sine of the angle included, which is 112 degrees, plus the other area is half of 80 x sine of 68 degrees. Now let's use the calculator to find these numbers. So we'll do 0.5 times 75 times 70 times sine of 112. That gives us 2433.8 rounding to 6. Okay, plus that is half of 80 is 40 times sine of 68, and that is 37.08. So it is 37.087. So that is what we have, times x. Now we can isolate x, taking away from 7,000 the number 2433.86 and then dividing by 37.087 to get the value of x. So let's find this. So we have 7,000 take away 2433.86 divided by 37.087, and that gives us 123.1. So I'm just writing 123 approximately. So we have our answer, and that is AB is equal to, so we have x, right? So now we need to find the perimeter, right? So we need to find the perimeter. So let's add them up. So perimeter is equal to sum of all the sides. So we'll have 123 plus 80 plus 75 plus 70. So adding them, we get the perimeter in meters. So let's add this. So we have 123 plus 80 plus 75 plus 70, and that gives us the answer as 348 meters, right? So that is how we get our solution. So we have answer as 348 meters is perimeter. Is that clear to you? So that is how we are actually going to solve this particular question. So it's a very good application of what we have learned in this unit. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.